Chapter 16 covers the TivaWare graphics library. In the lab, we'll use the Kentech LCD booster pack and watch our code display an image and graphics. We'll also use an on-screen widget to control the user LEDs. The TivaWare graphics library provides you with graphics, primitives, and widgets for creating an entire graphic user interface on Tiva-controlled displays. Some designers will go all the way to using Linux on a machine just to get a better graphic user interface. Here, you can use a smaller, less expensive microcontroller and design your own GUI. Note that while some TM4C129X devices have an LCD interface, the one on the LaunchPad does not. The interface to smart displays is done through a serial or parallel port. The graphics library consists of 3 layers to interface your application to the display. At the very bottom is the display driver layer. You'll generally have to modify this code for your display selection. We've had customers do this, and it usually takes them in the 2 to 3 day range to modify the display driver to fit with the display that they've chosen. The middle layer is the graphics primitives layer for drawing additional pieces to the screen. At the very top is the widget layer. Widgets are for tying touchscreen elements to code-based interaction. Your application code can interface with any of the layers. The design of the graphics library has been governed by the following goals: that the components have been written entirely in C except where absolutely not possible, that your application can call any of the layers, that the graphics library is easy to understand, and the components are reasonably efficient in terms of memory and processor usage. Those two goals can be somewhat at odds with each other. Code can be so efficient that you can't understand it, and if you can't understand it, you're not going to be able to use it. And that the components are as self-contained as they can be. Where possible, any of the computations that need to be performed will be performed at compile time instead of using up cycles on your CPU at runtime. Within the graphics library, the bottom layer is the display driver. This is the low-level interface to the display hardware. Routines for display-dependent operations, like initializing the display, backlight control, contrast, translation of 24-bit RGB values from the primitives layers to the screen-dependent color map. The display driver also contains low-level drawing routines, like flush, lines, pixels, and rectangle drawing. Hardware-dependent code will require modification, like connection to the display, the color depth, size of the screen, etc. The middle layer in the graphics library is graphics primitives. This layer provides drawing support for lines, circles, text, and bitmap images, as well as support for off-screen buffering. Many times you don't want to write directly to the display and have the viewer see you doing it. Instead, you can write to an off-screen buffer and then swap and show that buffer. Foreground and background drawing contexts are important so that you can put objects behind of or in front of each other. Colors are represented as 24-bit RGB values, and there are 150 predefined colors already provided in the library. Look in the Graphics Library User's Guide, and you'll find those predefined colors in the back. Also in the back of the User's Guide is a list of 153 predefined fonts based on the computer modern typeface. Also, Asian and Cyrillic languages are supported. Widgets are the top layer of the graphics library. Widgets are graphic elements that provide user control elements. They combine the graphical and the touchscreen elements on screen in a parent-child hierarchy so that objects appear in front of or behind each other as they're supposed to. This hierarchy can extend multiple layers. It also determines which elements on the screen will be updated when you request an update. Canvases provide you with a simple drawing surface on which you can place controls and graphical elements. Checkboxes allow you to select and unselect actions. Containers provide you with a visual element to group your widgets and controls together. Push buttons provide you with an on-screen button that can be pressed. Radio buttons allow you to select from a group. Sliders, either vertical or horizontal, allow you to graphically select a value from a predefined range. List boxes provide you with a list of selections that you can pick from. There are several utilities included in the graphics library that allow you to create compatible data structures that the library can understand. Rasterize converts your font into a font that the graphics library can understand. LMI Button creates custom shape buttons using a GIMP plugin. It will produce an image, for instance your company logo, for use by the push button widget. GIMP is an open source image manipulation tool. PNM to C converts a net PBM image file into a file understandable by the graphics library. Several image manipulation tools handle the net PBM image format, including GIMP. MakeString Table converts a comma-separated file into a table of strings for use by the list box widget. Like the Ethernet and USB modules, the LCD module is also a DMA bus master. The module can connect to character-based, passive matrix, active matrix, and OLED panels listed here. Take a look at the example shown in the TivaWare folders for more information on using this LCD module. Since the device on the LaunchPad does not have an LCD module, we will interface to the Booster Pack LCD over the GPIO pins. The Booster Pack that we'll be using in the lab is the Kentech touchscreen TFT LCD display with LED backlight. It's a 3.5-inch QVGA screen with 320 by 240 pixel resolution and 16 colors. It's designed with the XL Booster Pack pinout. The driver circuit and the connector are compatible with the 4.3-inch, 5-inch, 7-inch, and 9-inch displays from Kentech, so you can use the same Booster Pack board and swap out displays. In Lab 16, you'll use the Kentech LCD touchscreen display on the LaunchPad board to experiment with graphics library. You'll write code that places an image, text, and shapes on the LCD. Then you'll experiment with the touchscreen by adding a rectangular button widget that controls the LEDs on the LaunchPad board.